Hello. First model of atom was proposed by G. Thomson. Option 3. Hello. In this question, the radius of nth orbit of radius r. We know the radius given by n square times of the radius of the innermost orbit. So here r1, r2, r3, the ratio of 1, 4, 9, 16, directly proportional to n square. A naught is the innermost radius of hydrogen atom, that is 0.53 angstrom. So option 3 is correct. Hello, we know the formula of radius r naught a to the power 1 by 3. R naught is empirical constant. So r is directly proportional to a to the power 1 by 3. Option is correct. Hello, the transition take place for n is equal to 3 to n is equal to 1, means higher to lower is the emission spectrum. In hydrogen atom, like atom results in ultraviolet radiations. Ultraviolet radiation means n is equal to 3 to n is equal to 1. It means here this is higher to lower, but n is equal to 1, so it is the Lyman series. Infrared radiation will be obtained say from higher orbit to lower orbit, but n is equal to 1 is Lyman series, n is equal to 2 for Palmer series, n is equal to 3, 4, 5, 6, etc. Lower orbit is n is equal to 3. Higher orbit may be more than 3. That is the Paschen series. The Paschen series. N is equal to 4 lower orbit, higher orbit 5, 6, 7, etc. This is the bracket series. N is equal to 5 lower, higher is 6, 7, 8 like. It is the P1 series. Similarly, one is the Humphrey series. In all these, we are getting the infrared radiation, infrared rays. So here, if lower one is n is equal to 1, this is the Lyman series, and equal to 2 lower, higher will be 3 by 6, that is the Balmer series. It is an visible spectrum, n is equal to 1 for Lyman, UV rays. If say n 3, 4, 5 lower one, higher maybe 4, 5, 6 like, so this is all infrared radiation. Down to this an infrared for Paschen series brackets. So here 3 should be lower. It means only possible answer is 3. 4 to 3. So this is a Paschen series. Option 4 is correct. Although in this Bohr model of hydrogen atom, lowest orbit means n is equal to 1. So this is the having some minimum energy. Minimum energy here given by minus 13.6 upon n square electron volt, and minimum means n is equal to 1. This is the lowest orbit or ground state. Minimum energy. So option here is 3. Hello. The Bohr's second postulate is angular momentum L equal to mvr equal to n times h upon 2 pi, where h is Planck constant, n must be integer. So we used this explain the first theory, and second postulate here is angular momentum is integral multiple of h upon 2 pi. Or it is also quantization also. Option 2 is correct. Hello. The expression of total energy n is equal to say 1, z is equal to 1 for hydrogen atom. Formula here is 8 pi epsilon naught r. N is equal to 1, z is equal to 1. So option D, we should learn all these formula first. In this question, alpha particle scattering is given in the reaction. So let us say the graph here between the number of particles scattered, alpha particle scattered versus say the scattering angle. This sort of graph we are getting like some sort of 180 degree, 90 degree, 0 degree. Here roughly 1 crore alpha particles are moving roughly without deviation, and 90 degree deviation is roughly 4000 to 8000, and 180 degree scattering angle is roughly 8 to 10 only. So graph alpha particles are moving straight. For r theta is 0 degree, no deviation, so most of the alpha particles are moving almost without deviation. Here for Q, this angle suppose maybe 360 like so. Number of alpha particles are moving here. Yes. Now for P, maybe angle here 150, 160, 145 like that. Less, very less alpha particles are scattered here. If suppose not in the question, if theta is equal to 180 degree, means here very less, 8 to 10 only. Very few. So here, as per these informations, option 3 is correct. But for P, very few. For Q, some. For R, most of the alpha particles are moving almost without deviation. So option 3 is correct. Hello. In this question, taking the Bohr's radius or ground state is A naught, that is say 33 picometer or 0.53 angstrom. Now for lithium, for hydrogen atom, for lithium in the ground state means n is equal to 1. The basis of the Bohr's model will be about, we have to find out the radius roughly. So no, we know here the formula of radius n square epsilon naught h square upon pi m z e square. This is the question of the radius, formula of the radius. Now n is equal to 1. Hydrogen also, atom also, or hydrogen atom and lithium ion. N is equal to 1. Everything is constant here except Z. Z for hydrogen atom, that is 1, and Z for lithium, that is 3. Z is 3 for lithium atom. Everything is constant here, so radius is inversely proportional to Z. Now R for lithium, n is equal to 1. R for say hydrogen atom, n is equal to 1. This is 1 by Z. Reciprocal is का, so this will be 1 by 3 and this 1 by 3. Now R of lithium is equal to 1 by 3 of radius of first orbit for hydrogen atom. That is the P3 multiplied by 10 to the minus 12, was given in meter. It will be roughly 18. 10 to the minus 12 means 18 picometer. So option here is 3. Hello. As per the Bohr theory, for stable orbits, attraction force equal to centrifugal force. So here attraction force between the nucleus and the electron 0.4 epsilon naught E square divided by R square equal to mv square upon R, cancel हो गया. V square can be written as E square upon 4 pi epsilon naught m R, and V will be root of E square upon 4 pi epsilon naught m R. Option 3 is correct. Hello. From the angular momentum quantization condition for Bohr's or hydrogen atom, the radius of nth orbit is given. Now for hydrogen-like atom where Z is not 1, we have to find out the relation between radius and the value of Z. Here, as per the Bohr, attraction force and the centrifugal force, they are equal, mv square upon r. And the second condition, angular momentum L will be mvr equal to n h upon 2 pi. Now from these two equations we can find out r n square upon m h upon 2 pi whole square and 4 pi epsilon naught e square z. Question given for hydrogen atom, this is for any atom where z is not 1. Now n is equal to 1, everything is constant, but so r is inversely proportional to z. It means if you z increases, r decreases. Means option 3. Hello. In this question, ratio of the energies of hydrogen atom in the first and the second excited state. First excited state means n is equal to 2 and second excited state means n is equal to 3. Now we know energy for hydrogen atom is given as 13.6 upon n square electron volt, and n is equal to 2 minus 13.6 upon n square means n is equal to is 4. Similarly, E for 3. N is equal to 3, 13.6 upon 3 by square. Now 13.6 will be cancelled out. Now E2 upon E3 will be minus 1 by 4 to minus 1 by 9. Although we can cancel out minus also because of the ratio, but it shows the negative. The total energy cannot be positive. It is 0 at infinity. So this is the ratio. Although minus can be cancelled out, but in the option it is given, so no problem. Option 4 is correct. Hello, in this question, in Geiger-Marsden experiment, scattering experiment, alpha particles, say impact parameter is 0 degree. 0 impact parameter 0 means central line. So scattering angle is just bouncing back, so 180 degree. If B is large enough, then theta is almost 0 degree. It means alpha particles are moving almost without deviation. Where here case when B is equal to 0, theta is 180 means alpha particles are bouncing back because of the repulsive force from the nucleus and the alpha. So here option 1 is correct. Hello. In this question, Bohr's idea was confirmed permanently by these two scientists, Planck and Hertz. So option 4 is correct. You have to learn it simply. Hello. In this question, binding energy of hydrogen atom, considering here is the binding energy is given by this formula, where m is mass of electron. On the other hand, if say one decide to work in frame of reference where electron at rest and photon is moving around, the binding energy is given by this, where m is the mass of the photon. So this option is not correct. Why? Because if you are taking electron at rest, it is accelerating. Acceleration in electron means it is not in following the law of inertia. It is a non-inertial frame of reference. That's why this second case is not possible. Because of this, it is in non-inertial frame of reference. So option 3 is correct. In this question, Rutherford experiment, the size of the nucleus is about Fermi level. So option 3 is correct. Size of nucleus is very small, the order of Fermi level. So option 3 is correct. Hello, in this question, binding energy of electron in the ground state of helium, it is given here 24.6 volt. The energy required to remove both the electrons. So here, remove the first electron. Energy required here is given in the question for first electron is 24.6 electron volt. Now energy required to remove the second electron, that is given by 13.6 electron volt upon n square, and here is Z. This is the formula here. This is 13 minus 13.6 upon n square electron volt is for 13.6 electron volt for hydrogen atom, and now for any atom the formula here is minus 13.6 upon n square Z square electron volt, and here in question Z is equal to 2 for helium and n is equal to 1. So we are getting here 13.6 to 4 divided by 1, that is coming here after calculation, that is 4.4 electron volt. Now the total energy required for both electrons, simply 24.6 electron volt energy required, it will become plus 4.4 electron volt. So the total energy required for removal of both the electrons, we add roughly it is coming here 79 electron volt. So here option 3 is correct. Option 3. Say Bohr's model cannot be directly applied to calculate the energy levels of atom many electrons, because if you are taking say one electron means is the central force between the electron and the nucleus. But if we are taking the many electrons, which are not the central forces, so how can you add? After sum can be taken only. So that is why first option is correct, because they are not central forces. Hello, in this question, 10 kg satellite circles around Earth once in every 2 hours in an orbit having a radius of roughly 8,000 km. Assuming the Bohr's angular momentum postulate means second postulate to satellite, we are taking satellite as electron and nucleus as Earth. Then quantum number and we have to find for this term, Earth and term. Here, if the Bohr's model is correct, then we can write here second postulate L angular momentum is equal to mvr equal to n h upon 2 pi and must be integer. As per Bohr's and must be integer. Now, for this system, Earth and the satellite system, we can calculate n equal to mvr and 2 pi upon h. Now, what is a v? Velocity, we can find out velocity can be written as distance on time. So, m upon h and 2 pi r. We put all the values here. M means 10 kg, 2 pi 3.14 and radius 8,000 kilometers upon h Planck constant 6.62 into 10 power minus 34 into t 2 hours can be converted into second. If we solve it, we are getting the value of n is roughly 5.3 into 10 power 45. So option correct. Here in this question, we have to find which energy is not possible. Here we know energy, total energy, or maybe say E. Total energy is given as 13.6 upon n square electron volt. So if n is equal to 1, it will be 1 minus 13.6 electron volt. For n is equal to 2, E2 or second orbit, this is minus 13.6 upon 2 4, so this will be minus 3.4 electron volt. Similarly, n is equal to 3, it is a minus 1.51 electron volt equal to 4. E4 will be minus 8.85 electron volt, n is equal to 5. E5 will be minus 0.54 something. So, if the electron is transferring from one orbit to second orbit, energy required here. So, this way, if E1 minus E2, E1 minus E3 and 2 minus E4, E3 minus E5, this way all combination, permutation, combination. So here, if we take say energy possible E1 to directly finite means positive 13.6 electron volt energy required here to remove the electron from the innermost orbit. So 13.6 means option 4 correct here. And suppose if we divide subtract E2 minus E3, we are getting roughly 1.89 electron volt or 1.9 electron volt. It means option 2 is also correct. And another possibility is here E3 minus E4 is 1.51 minus 0.85. The energy required here is 0.6 electron volt, roughly 0.65 electron volt. Your option 1 is also correct. But from any combination 11.11 electron volt energy difference, we combination में नहीं मिल रहा. So option 3 correct as is not possible. Not possible.